Hey viewers, welcome back to my channel. And today we are going to solve a very important DP problem, partition equal subset sum. So the problem states that given an integer array norms, return true if you can partition the array into two subsets such that the sum of the elements in both subsets is equal or false otherwise. So one array is given and we need to check whether we can divide it into two subsets such that the sum of numbers of one subset is equal to the sum of numbers of second subset. For example, here you can see one subset is 155 and another subset is 11. So the sum is equal here. Okay. So that means we are able to divide it in such way. So that's why we return true here. Okay. So how can we approach this problem? Can we simplify this problem a little more? Like first we will find the sum of all the numbers, and if it is odd, then definitely we can't divide into two subsets. So obviously we will return false. Okay. If it is even, what we'll do is for both the subsets, the sum will be same only. So why can't we take only one part? And if we find that sum, then obviously the rest of the if we get the sum of rest of the numbers, obviously it will be same only. So now the problem boils down to, in this case, let's take only 11, only one part, and we'll try to find out whether it is possible or not. Okay, so the approach is we'll iterate through. So here we'll first use first we'll go through the recursive solution, then we'll optimize it, then by memoization technique, then we'll again convert it into tabulation format. Okay, now how can we approach this? We'll iterate through all the numbers, and for each number we have uh, two choices. Suppose let's take this scenario. Either we can take one or we cannot take, like either we'll take one or no. In the second also, either we'll take five or not, right? So like that, for each is number, we'll have uh, two choices. Okay. And finally, whichever is true will return true. Okay. And yeah, so here the base case will be true, right? The base condition. If it if it'll keep adding it, like if it becomes if we are able to reach the length, okay, we'll go one by one for each number. And if we are able to reach the end and the remaining sum is not zero, then we'll return false. Otherwise, if we are if the remaining sum becomes zero, then we'll return true. Sorry, if we reach if the remaining sum is not zero, and if we reach means if we reach the end of the array, okay, or like if the remaining sum is not zero in both the cases, okay, we will return false. Okay, either or. Okay, either or if we cover all the elements, then also we'll return false, or uh, if we if the remaining sum is less than zero, then also we will return uh, false. Now let's code it up. So first, let's find the sum. Now let's find the. Okay, let's check if the sum is odd or even. If it is odd, then obviously we'll return false. Okay. Otherwise, we will call the recursive method. So I'll pass nums here, and also I'll pass the index like arch 0, and also I'll pass the half of the sum. Okay, because second part will be taken care by itself. Okay, so I'll just write sum by 2 and solve is our recursive method. So let's write index. I declare index here, then I'll declare remaining sum. So each time it will keep decreasing. Yeah, so base condition is if the remaining sum becomes zero, right? If remaining sum equal to zero, that means we are able to make it. Okay, so return true. One more base condition is also there. If the remaining sum is not zero, then control will come here. If we covered the length, that means if the index equal to norm start length, if the index equal to norm start length, or the remaining sum is less than zero, sum is less than zero, then we'll return false. Okay, this is our base condition. Now our main logic is like we'll call the recursive solution here, solve, and here we'll pass. We have two choices, right? Either we can take it or we cannot take it. Okay, so first condition is if I take, then what will happen? I will pass norms. Then in the index, I'll pass index, and uh, if I take it, then I will subtract sum from remaining sum. So sum minus num, I'll subtract it. Num means what I'll write norms. I'll use the index here, right? Or I, if I take this, then I'll subtract the norm. If I don't take it, then I'll just pass as it is. So, okay. So let's run it and try. Sorry, it should be Boolean. Okay, it works. Let me submit the code. And since it is the brute force approach and we have not optimized it, it will give TLA. It is giving the wrong answer. So now our issue got fixed and it gave daily. So now we need to optimize optimize it. Here the time complexity will be 2 to the power n. So now we need let's optimize it. So if you see the states here, right, it will be index and remaining sum. Okay. So what we'll do, we will declare one memo. So it will be a 2D array. Will be used applying the memoization technique here. And let's declare the array. Okay. So first will be like, let's see, memo new integer array, and here the size of the this will be the length of the numbers. Okay. So I can write nonstop length, and in the second array, the size of the second dimension is like the sum by 2 plus 1. So what we'll do here, instead of going to this logic, we'll check and we'll return. So now we need to store the value, whatever we are returning from here. So let me declare one variable result, and let me store this value, and let me return the result here. Okay. So now I can just store this result in the memo. First, I'll store the result here. And before coming to the actual logic, let me just check whether this memo is not on, it is null or is not equal to null, then just return it. Let me run it now. So we forgot to pass the memo here in the method call. We forgot the declaration as well. Okay, if it is okay, instead of I should make it Boolean here. Boolean here also. I need to make it Boolean. It our test cases got passed. Let me submit the code now. And it works successfully. Okay, so we have already optimized the solution, our recursive solution using the memoization technique. Okay, now what is the time complexity here? The time complexity will be the product of the product of the remaining sum and the length of the array norms. Okay, so this is our solution with the memoization technique, and now we're going to solve with the tabulation approach. Okay, So in tabulation approach, it is also known as bottom-up approach. So this thing will be same for both. So let me write it. Now, if the sum is odd, then we need to return false. If the sum is equal to 0, that means it is odd. We'll return false. And what else? Now we'll find the length n equal to norm stud length. And here, if we see when the remaining sum is 0, this is the base case. Okay, this 2 is the base case. Okay, so first one. Okay, if remaining sum equal to 0, we need to return true. That means in tabulation, okay, it will come under our initialization section. Okay, and in the negative part will not be considered in tabulation technique. Okay, and it may be used as a condition check. Okay, so yeah, let me initialize for. So first, yeah, we'll declare a DP. Okay, uh, two-dimensional array of type Boolean if equal to. So the size here, if you can see, the size of the memo is number of length. I mean the length of the numbers, and here it is the target plus one. So here what we'll do, the size of the row will be n plus one, and the size of the column would be target. Let me declare a target here, which will be the sum by 2. Okay. Here directly you have written sum by 2. So I am just naming target, the variable name target, and which is equal to sum by 2. So the size of the column will be target plus 1. Okay. Now first I'll initialize when our target value is 0, I'll initialize all the rows as 0. Okay. I mean uh sorry, true. So let me iterate through all the rows I equal to 0, I is less than n, I plus plus. So dpi, and the target value is 0, so that's why I just took the 0th column. So I just assign true value. Okay. Now, if you see here, if you see the states here, okay, what are the states? States are like in this recursion, which values are changing? Index and remaining sum. So what I'll do here, I'll take two for loop. Okay. And which will be the outer for loop? It's the index. Okay. I'll iterate index in the outer for loop. I equal to 0, I less than equal to n, I plus plus. And the inner for loop will be our remaining sum, means will iterate till the target. Okay. So for I, let me take arch s. Okay, s equal to 0, s is less than equal to target, s plus plus. So two for loops are done. Now inside the for loop, what I'll do is I'll just, now we need to do the transition. Okay. So what I'll do, just assign the dp is equal to dp I minus 1s. Then here I'll put the transition logic here. So dp of either we can skip the element. So dp is, or we can take the element. So dp of I minus 1, and here s minus norms I minus 1. Your index is I minus 1. Okay, so that's why dpi minus 1, s and minus s I minus 1. Here one more thing we need to consider, like if s is greater, if less than this element, norms I minus 1, it will throw array index out of bound. So that's why I will check here. Okay, for negative condition, we'll put a check here that this particular expression, or we can put s is greater than or equal to norms I minus 1, so that negative value will not come. Okay, we're done with this. Now what we'll do, we'll just return TP of n and target. Let's run it. So since the ith element we have already considered here, so both will start from 1. And it runs successfully. Let me submit the code. And yeah, all test cases are passed, and we are done with our tabulation approach as well. Time complexity is n into target. Also, the space complexity is n into target. Thank you.